Hello, and welcome to reInvent. And welcome to today's session on the enterprise fast lane, or what your competition doesn't want you to know about enterprise cloud transformation. Did you enjoy Werner's keynote? Yeah. Me too. I always look very much forward to Werner's keynote. And I was very, very happy that Werner themed his whole keynote around transformation, because this is what we're going to talk about during this session. How does transformation actually work? Now, Werner covered a lot about the technical aspects of transformation. And during this talk, we are going to cover the cultural aspects of transformation. My name is Constantin Gonzalez. I'm a solutions architect with AWS in Germany. And I get to talk to a lot of large enterprise customers. And as they try to adopt cloud computing, they struggle with a lot of issues and problems. And most of these issues are non-technical. So over time, I found myself in more and more discussions around cultural things, around processes, around organizational things that customers need to learn as they adopt cloud computing and the digitization strategy in their companies. So what are we going to cover? We're going to see how to make it easier to become cloud native for your companies and organizations, how to transition your organization from something that is a little bit more static and difficult to change into an evolutionary architecture approach to building things in the cloud. We're going to see how cultural change can work across your whole organization, no matter how big it is. And we're going to see this based on real-world things that customers have actually done today, so nothing theoretical. And hopefully, by the end of this talk, you will walk away with a couple of tools and ideas that you can employ in your own organizations, in your own company, as you go through your own transformation. Because we all know that a cultural transformation is always an individual thing. So cloud computing is actually about a completely new form of IT. And by using cloud computing, you get access to unlimited resources at no financial risk through the pay-per-use model with a software-defined dynamic architecture, which is 100% automated. It's flexible, deployable in minutes, worldwide, secure, and robust. All of these great things you're learning a lot about at reInvent. But if you want to boil it down to a very simple, single thing that cloud gives you, essentially cloud computing is always about having no physical limitations whatsoever in terms of what you can do with IT. And that is the greatest thing about cloud. It removes all of the physical limitations of IT so that you can start thinking freely about what you want to do with your IT solutions. And most of our customers first come to us and they talk to us about lower cost. And yes, of course you can address lower cost with the cloud. And if you're interested in lowering your costs, I would like to pull in a plug here. So visit the session ARC315 tomorrow, which is all about how to optimize your cost structure on cloud. But the other thing that customers expect us to deliver with cloud is better agility. And I think this is probably the biggest benefit to using cloud computing for organizations, because it enables them to be fast, to deliver things with a very, very short time to market, to be more agile, much more innovative as they enter a digital world. So how does this agility thing really work? Now, I see with many, many customers that agility are really about two things. There's technical agility, and that is what is covered on most talks here at reInvent, but there's organizational agility. And that is what we want to focus during this talk. How do you manage your organizational agility? How can you make your own organizations much more agile? And that boils down essentially to culture. So the best way to learn about cultural transformations is actually to listen to our customers. So I'm very, very happy to have Christian Deger here join me on stage. He's chief architect with Autoscout 24, and he will tell you their story on how they manage their own technical agility, how they manage their own cultural transformation. So please welcome Christian.
Hello, everyone, and thanks, Konstantin, for the introduction and for the opportunity to talk about our story. I'm going to talk about our ongoing journey from our monolithic data center setup to microservices in the cloud. I'm with Autoscout for over 6 years now, and We are based in Munich in Germany. And what does Autoscout actually look like? Autoscout is the largest online car marketplace Europe-wide. It's like Auto Trader in the US. And our goal is to make the entire experience of buying and selling cars as simple, efficient, and stress-free as possible. We have about 2.4 million used car listings on our platform for the users to search. This is how our cash stack setup look like. This is where we still make the money. This is our data center setup. We are, or used to be, a Windows.NET shop running ASP.NET using an Oracle database. Everything is virtualized using VMware. We are running around 2,000 of those virtualized servers in 2 data centers for disaster recovery. And the whole setup is optimized for mean time between failure, meaning expensive hardware with redundant power supply, and the idea is that the availability is guaranteed by optimizing that nothing breaks there. Nevertheless, this platform supported the growth of Autoscout for many years, and in accordance with this platform, also our way of working was centered always around agile and lean principles. This is our organizational setup, how it was about 2 years ago. We had the typical development department and the operations department. And the development department was driven by the wish for change, and the operations department was driven by the need for stability. So there was always a friction between those two mantras. And when the software developers wanted to release a new version of their software, they packaged up the software and threw it more or less over the virtual wall for the operations department to run it. So there was a disconnect between those two. The engineers actually didn't know how the application was run in production. A good example for this is if the software developers introduced a performance degradation, operations department just spin up additional servers to compensate that. And also the operations department, and this is typically in many organizations the case, has introduced a ticket system to funnel the changes and to protect themselves from that. So for the software developers to actually stand up a new service, they need to write a ticket, specify how many VMs they needed, what size those VMs should have, what software should be installed, and then they had to wait until this appeared. So at that time, there was within Autoscout already a group that was anticipating change, that wanted to get rid of the silos, and they wanted to be faster by getting out of the data center. When we look at this typical enterprise IT adoption cycle, we didn't want to end up on the red line. We wanted to be at least on the green line with the rest of the world. But within Autoscout, there was resistance against these changes. So there was a small group who wanted to change, and there was resistance against it. We were talking about how cool the things are that Netflix does and how they blog about it and what advancements they have by using the public cloud. But then we were told, we are not like Netflix, we are not in the streaming business, this does not apply to us. And also when talking about the advantages of public cloud, we were told, you don't need a public cloud, we have a perfectly running private cloud for you here, and everything you need from the public cloud we just built for you. In the end, we still just had a good virtualization, not a public cloud. But then we were lucky. In the end of 2013, Autoscout Holding, our mother company, was sold to private investors, and a new CEO came on board. And the new CEO asked questions like, are you ready for the future? Do you attract talent? And then we were thinking about what he's trying to tell us. And looking at .NET and Windows, yes, we were able to hire good .NET developers. But especially in Munich, those .NET developers typically came from insurances or from banks. So they were good .NET developers, but we needed to teach them how the internet actually works, how we want to roll there. So we couldn't profit from that much from their experience. And we also realized that a lot of the innovation now comes from different ecosystems. We now heard that C# is supported in the Lambda functions, but in reality, .NET and a lot of the internet things are not that well aligned. So, and what does a 21st century company actually look like? These are the companies. This is just a small collection that we're looking out for. We're looking at the things Netflix, Uber, or LinkedIn has done. And also, we realized that nowadays, the innovation in our business is no longer coming from the traditional enterprise suppliers like Oracle, IBM, or Microsoft. The innovation is coming from companies like that. For example, Kafka, which was written at LinkedIn. So we wanted to become like those companies and also live in a technology ecosystem that is similar to those companies, that we can actually profit from these innovations. These are some of the traits we attached to those companies which we also aspired to become. After thinking about all of this and reflecting upon it, we realized, okay, we are good, this works for us, but we are not really great. We need to change something. And we also realized that we need to change many things, that this is not a simple transition, but there are many things involved to actually change things. And we also realized that despite that we want to change many things, we also need to start small. We don't want to overwhelm the whole company. We want to treat many of the changes actually as experiments so that we can learn from them and improve upon that. These are the things we set out to change. We want to move away from .NET Windows to JVM Linux. Especially the Windows in contrast to Linux part is very important for us because Linux is way better to automate than .NET was. And as I already told you, the JVM ecosystem produces way more internet-capable tooling than is available in the .NET ecosystem. We also want to go from a monolith to microservices. I will talk more about microservices later. And we want to move from the data center to AWS. And we want to get rid of our dev and ops silos to a truly collaboration culture. And we also realized that we don't want to do a technical migration where we just switch out the underlying platform and rewrite everything in a different language. The idea was that we actually come out with a new version of Autoscout on the other side. So we also wanted to involve product people. Now, those are many changes we wanted to do at the same time. And of course, there's risk associated with that. And then we ask ourselves, is there a step in between? But we realized, no, actually, we need to do all of those things. It does not make sense. We didn't want to end up in an intermediate step where one of those topics is not addressed. We then start preparing for the change, and we're reasoning about how to actually do microservices. These are the famous Death Star diagrams. Amazon in 2008, I totally assume that this has become more complicated in the meantime, the number of services contributing to Amazon, and Twitter from 2013. So you can see a lot of services with a lot of dependencies. These are really complicated distributed systems those companies have to deal with. And we realized this is not what we're gonna pick as a starting point. We want to do a different kind of microservices in the beginning because our experience in distributed systems is not that evolved that we could tackle an architecture like that. So we picked a flavor of microservices which is called self-contained systems. The idea around self-contained systems is that you have one vertical slice of your application which is contained in the self-contained systems and is centered around a business capability and built and run by one team. So there is an association between those self-contained systems and teams, and these are a vertical slice from end to end for one business capability or bounded context. Another trait of those self-contained systems is that they also contain their own UI. So what we didn't want to end up with is to have an UI monolith sitting on top of API services, because then one of the promises of microservices to actually decouple your architecture would be limited to the services themselves, but all teams would be coupled at the UI again. So the self-contained system contains its own UI and is typically integrated by a UI composition. So a normal request to our website should typically be handled within one of those self-contained systems without talking to other services. And to represent different capabilities on one page, those services are composed at the UI level. In November 2014, our first team started with this transformation project. We have done a lot of preparation before that, and we started with one team that was a mixture of software developers and operation guys, and some external help that we put also in there. And this first team had to do everything. Create the AWS account first. We need to set up our MacBooks. We worked on Dell before that, of course Windows and .NET. And we need to learn, we picked Scala as a language. We need to learn Scala, how the JVM works. So this was point zero. We had a lot of preparations before that, and the team was also very tightly aligned. They had the same idea how to approach things, but we started to experiment. So this team was supposed to be you build it, you run a team. I will talk about this a little bit later. And the idea was that this team is responsible for the infrastructure, for the delivery, and the service they're at first gonna start. What also happened there, from a company perspective, from an organizational perspective, those were treated as the harmless team. So nobody was afraid of what they're doing because it was just one team and they could totally ignore what they're doing. And the idea was then to ramp that team up, split it, add more team members, make 2 teams out of that, make 4 teams out of that. But we realized that by splitting up into about 4 teams at that point in time, that our original ideas, where the first team was very tightly aligned, were not longer that obvious to the new team members. So we needed to do something to spread our original idea and to confirm how we actually wanted to work. This is then when we came up with our IT principles. You don't need to read through all of them. I will touch many of them in the remaining parts of the presentation. But the overall idea is that we have strategic goals which are aligned with business, and we have architectural principles to support those strategic goals, and we have design and delivery principles that also support those. And what makes those principles very valuable to us is that this was born out of the teams working with it. This was not a top-down value discussion. These are the values we need to live by. This was coming from within the team and then, of course, aligned over the company. And it also helped during discussions, during meetings, to actually align on the way we want to work and what's important for us. And it's also a valuable tool to actually find out the gap between what you actually aspire to do and the reality. So this is also a constant reality check for us if we are still on the right path. On the strategic goals, I will mention the reduced time to market. During all of the keynotes, you have seen the notion of being fast is the important thing. Being fast, getting fast feedback, getting products, features in front of the customer to get feedback from them. This is the same for us. So speed is the most important one. There are a lot of other things on there, but I won't go into details. Important, if you want to try something like that in your company, please don't copy those principles. The valuable part is the discussion and coming up with them and shaping your own. Many of those are generic enough that you could reuse them, but then it wouldn't be as valuable as when you would have the conversation around them. When everybody says speed is the important part, this is why speed is important. This is the build, measure, and learn feedback cycle known from lean startup. And the faster you can iterate through that cycle, the better the products are and the better is the product fit for your customer. You want to build the right thing for your customer. When talking about microservices and architecture, it is very important to know and adhere to Conways Law. Reality verifies that this is a law. What does it say? In essence, it says your organizational communication structure will be reflected in your architecture. And also the inverse is true. If you want to end up with a certain architecture, you need to set up your organization accordingly. So we wanted to have a microservices architecture for various reasons, and this also means that your organization needs to be set up like that. Meaning you want to have empowered self-organizing cells, autonomous teams that are organized around business capabilities, as you have seen before with the self-contained systems. This way, Conways Law plays to your advantage. The teams have very high communication bandwidth within the team and a lower communication bandwidth across the teams. And this is also how your service should look like. And as you have seen with the self-contained systems, they follow the same principles. So those services then should also be decoupled. This also means you should build products and not projects, because those teams are centered around the product. You also need to make sure that you respect the domain and the bounded context, meaning you all know your domain or you are exploring your domain, and you need to make sure that your services and your teams are aligned with those bounded contexts. And this then allows you to make fast local decisions. So this setup optimizes local decisions over communicating outside of the team and getting everybody in agreement. So this is the part where you then can be fast. Another very important aspect in there is you build it, you run it. Those teams take ownership of their service. They're responsible for shaping, building, running, and maintaining their service. So they're not only writing the code, handing it over to somebody else, and then just go home. So when they now write a service that breaks in the middle of the night, the team is on call. Somebody from the team is woken up to fix that service. There is nobody from ops who is doing that work and then has to fix a service he actually does not know anything about. The team is responsible for running it. And this closed feedback loop that you are actually responsible for your runtime behavior of your service leads to resilient and robust services, because the team does not want to be woken up in the middle of the night. So this leads to the right systemic behavior. This also means that the team is not only responsible for the runtime behavior, but for the whole product lifecycle. So for getting the customer feedback and improving on the product. So they have true ownership around their service with the according freedom and responsibility around the service. To make the cultural change more explicit, we also agreed that we now call ourselves all engineers. There used to be the software developer, there used to be the operations guy, and we want to get rid of this heritage, and we are now all calling us engineers. And this also means that we needed to learn how we actually collaborate within a team. So having all those different T-shapes now be within a team means that they need to pair, that they need to work together, that the whole team in the end is capable of doing all the work that's required from them. We also did some experiments around that, how the team actually should be set up. There was a fear from the operations department that during the ramp-up of the teams, they didn't have enough exposure to AWS because only few of the operations guys were part of the transformation in the beginning, so they wanted to do a rotation so that the operation guy within the team had a bi-weekly rotation and a new guy came on board. This experiment failed. The team stability did not work out, and we stopped doing that. But this is one of the things we learned along the line, that all those cultural changes, you actually don't know how they work out. There is no perfect blueprint for everything, so we just tried things out, have seen whether they worked, then kept them or changed them and tried a new thing. Oops. Another notion around microservices is that you also can have a polyglot environment, meaning the team can make different technology decisions than the team next to them. But what we don't want to end up with is that now we have a zoo of technologies to support. So what happened in reality is that the first team and the first teams just picked, due to experiments or to prior experience, made some technology choices and built tooling around that. So for example, we decided to go with the Scala Play framework. We decided to go with Terraform, didn't work, decided to go with CloudFormation, then set up a continuous delivery pipeline and build tooling around that. So when the third, fourth, fifth team came aboard, they learned how this stuff worked and just picked up those convenience offerings, but they were not forced to. So if they had a good reason, or they knew that their problem could be solved better with a different technology, they were free to pick something else. But when they just followed the trail of which was made by the previous teams, it would be easier for them to bootstrap new services. We had a service template for a default setup, which made it easier for them. But still, a team could deviate from that path and make different choices, but then they need to support their technology decisions and be actually responsible for that. So if their product manager actually agrees that they now it makes sense for them to deviate, they're free to do so. Another thing we realized, when you have a lot of those autonomous teams working closely together, this setup is optimized for the local decisions within the team. So within a team, all things are typically solved, but you're missing out on the cross-team communication. This is when we came up with our guilds. Those are self-organized common interest groups that work across the teams. So most of those guilds meet once per week. Some of them do work, some of them make decisions, some of them are just aligning and discussing new topics. For example, we have a macro architecture guild, which is actually responsible for decisions on a macro architecture level, which all teams need to follow, things like security, logging, monitoring, or contracts. Now we have an infrastructure guild, a front-end guild, and a QA guild. And all of those guilds are trying to share the knowledge across the teams and getting good working practices aligned. I'm now coming to a topic which is very important for me. We heard this also today, the continuous delivery approach or the DevOps culture. Who is doing continuous delivery from you? Okay, so very important for the rest of you. This is one of the practices which really helps you to take advantage of what software can do, what you heard today, and also what enables you to even be faster if you go to the public cloud. Why are we doing continuous delivery? As I already mentioned, we want to get fast feedback from real users. We want to have a build, measure, and learn cycle. So code changes need to go out there as fast as possible. And there's always the fear, if you do something more often, the danger of breaking things increases. As you've seen on the picture with the operational silos who was striving for stability, and one way to stabilize things is you don't touch them, you don't change them. But continuous delivery actually, and this is proven over and over again, if you increase the number of changes and you do it right, your failure rate goes actually down. Jess Humble has done a talk on that where he made a survey, and then the talk was called Science the Crap Out of DevOps, and he more or less has proven that continuous delivery has a positive impact on failure rate and overall IT performance. When I started at Autoscout, we were releasing our monoliths once per month, and this was a painful exercise. Nowadays, every one of our teams is doing many releases per day, and as you have heard from other companies during the keynotes, the larger the company, the larger the number of changes, and not the other way around. This is how it should be. Now, the simplest delivery pipeline you can conceptually build so as it works in our data center. We have application code for one service in one repository on GitHub. Then we have our commit stage, where the software is built, unit tests are run, and all things are verified that this version of the software is actually ready to be released. We then package that software up and store it as an artifact, typically on S3 or other artifact repository. And then comes the continuous delivery stage. We actually pick up that artifact and roll it out to a predefined set of servers that were set up in the data center and update the software version on those services, ideally without interruptions, and then the new version of the software is running. The whole pipeline is, of course, totally automated, allowing you to have repeatable and reliable and traceable changes to your software. So everything goes from your repository through the pipeline into production. But what's wrong with that picture? As you have heard before, the servers were under the control of the operations department. They did patches to those servers, they made configuration changes, they added servers, they removed servers, they fiddled around with the load balancer in front of that. So a lot of changes affecting the production environment. We were not under control of this continuous delivery pipeline. And of course, many of those changes have the potential to actually lead to an outage. So on AWS, you can go a step further. This is how our delivery pipeline now looks like on AWS. Now we have a repository for our service where not only the application code is living, but also the infrastructure specification. And in the commit stage, we still build the software artifact, but we also store our infrastructure declaration, meaning that then in the continuous delivery stage, we are applying those infrastructure changes to the infrastructure for the service. And by doing that, also the EC2 autoscaling group makes a rolling update of the instances in there. And when the new instances are started, the new software package is installed on them. So what this gives us now is that also the infrastructure changes are repeatably, reliable, and traceable applied to our production environment. There is no outside change coming to those servers. We're doing that mostly with CloudFormation, autoscaling tools, some glue code around that, but AWS provides everything to make this a rather easy approach to do. The advantage of doing it like that, in addition, is that you now can make sure that there are no other changes to production. So using CloudTrail, we are able to alert us when a change is applied in production which is not coming through the continuous delivery pipeline. So if an engineer goes into the console and changes a DynamoDB setting, everybody gets an alert. Somebody was fiddling around with the production setting. So this is a very powerful tool with some simple conventions. You now can make sure that your infrastructure in production is actually driven by repositories and completely traceable. Infrastructure as code. We heard this today, cattle, not pets. This is also part of our delivery pipeline. None of those servers survives a software update. New instances are created during the update. Phoenix servers or immutable servers, everything is recreated for a new software release or for a configuration change. So there is no configuration drift. Every server looks like the same. Everything is immutable. And no outside changes coming in. What you then also can do, you can have an alert on the age of those instances that are running. In prior times, you could brag how long the uptime of your Linux server was. Nowadays, this is not allowed anymore. After 2 weeks, you get an alert. The instance is too old. You need to replace it with a newer instance. This is due to security patches are coming through the base AMI, meaning in order to make sure that all the servers we are running actually have up-to-date security patches, we require them to not get too old. There is a trade-off in that. By restarting all those EC2 instances during delivery, the delivery takes typically around 20 minutes, mostly due to the EC2 startup phases. This is something where a container approach could help, and this is also something we are working on. Oh, this was back, sorry. This is the next one. Now, we've talked about in the beginning that the self-contained systems contain their own UI, and we need to do UI composition, and also that we are in a transition phase. This is how our network setup supports this. We have simply CloudFront as an entry point to our application, and for all services for which we have not yet built an AWS service, the traffic is just routed back to the data center. But for those services which a replacement has been built, it goes to our UI composition layer, which we call Jigsaw, which in essence is just an Nginx with SSI includes and some mod page speed wrapped around it. So what this allows us is that, for example, the header and the footer or other parts of the services which are contributed by different services are then using the SSI includes composed to make a whole page out of them. This is our version of the next iteration, Hamburgers, not cattle. We heard today the mantra, not cattle, but the whole herd from Werner. So what our picture should describe, we are not longer interested in many cases in the cattle, but only in the meat. So meaning serverless Lambda functions, and of course, this is also what we are using in many places, for example, as glue code in our event streaming pipeline. Just as a side note, event streaming and getting events off of the application in addition to the typical log shipping, hopefully most of you are doing, is relevant for microservices also, because you no longer have a central database on which you can do your ETL for your data warehouse, so you need to get the data required for behavioral analysis or other analytics or other users out of the server. So in the end, we have this event streaming pipeline built on Kinesis, Lambda, and S3 and Elasticsearch to actually get the data out of there. One advantage of doing that directly from the application and not via log files is our applications are now writing directly into Kinesis, and they're using a JSON structure to log. So it's structured logging, no longer log lines intended to be written, to be read by humans, but actually exposing JSON, which is ready to be consumed by others. this was something very interesting for us when observing what's happening when you give teams autonomy and responsibility. Our teams need to run their service, and nobody told them to build a dashboard like that, but they just did it because they felt responsible and they want to get the operational insights. So they're looking at their latencies. They're also smart enough to look at the 99 percentile of the latency, what CloudWatch now also supports. They're also, on the right side, you can see that they're also interested in their AWS cost. So they have on their dashboard the cost of their service from the previous day. They care about that. You can't see that on the left side. They also have the Ops Genie alerts on there, so they are on call for their service. They have their page speed on there, so they get a lot of insights into their service, how it behaves, so that they're actually able to be a you build it, you run it team. And this kind of monitoring is also very important if you're in a microservices world, because your production environment changes all the time. So doing a lot of testing during your delivery phase is still important, but you can't actually verify that what you are doing integrates with all the other services that are running in production. So constant monitoring of your production environment is becoming the new testing. This is where you need to make sure that everything is working. What also Werner talked about, which we will do in the near future, I'm hoping, which is missing from that picture, there are no business KPIs on there. There's no, Werner called them the canary today. So what's really important for us? Up until now, our teams are still looking at the operational metrics. Another thing we learned, and which actually simplifies a lot of things for us. Back in our data center, we had a staging environment which should look like production. And every software release was first tested on ref before it went into production. And what we learned there is that it was an ongoing struggle to keep this ref environment actually like production. So a lot of those deliveries were red due to some configuration mismatch or another service which you need to integrate was actually just broken in that environment. So a lot of effort, and still we couldn't be confident that the service would not behave different in production. There was a different load in production. The users behave different there. So we actually tried what would happen if we leave out the staging environment. Is this something we can do? So now we tried that, and it actually works. It falls under the mantra, be bold, but not stupid. So you need to do some additional things to actually be confident that you can deploy your service into production. For example, doing a canary release where you're trying out that the service not under production load, but not serving the results back is working. You can do blue-green delivery. You can do shadow traffic, meaning that when you want to replace a service, you're just forwarding the original traffic to this service also to make sure that it's behaving like it should do. And we also introduced consumer-driven contracts to verify that the services that will meet in production actually have contracts that match up. And the consumer-driven contract is also an example where in a microservices world with many releases, things behave different. Your microservice that you are deploying into your staging environment will meet services in a different version than they might actually be in production because the other team is also just doing a service release. This worked out quite well for us, simplifies the whole setup and actually makes your delivery pipeline faster. And then one learning we made. As I told you in the beginning, we were trying to split up the teams to emphasize the learning in the teams. So there were some experts in a team, then we split it up, added engineers that were up until that worked in the cache stack, and then had two teams. The advantage is due to pairing and knowledge sharing, the new teams learn the new world and the new way of working and AWS and everything quite fast. But the disadvantage is that you're destabilizing your teams. And this was one of the painful learnings that we actually, due to the splitting, didn't allow the teams to actually become performant teams. So we changed our approach, and now when we have an experienced team and want to add another team to the new way of working, we are not emphasizing the learning of the new team anymore. They need to learn on their own pace, and the experienced teams are working as coaches to help them, but they are not part of the team anymore, and let them learn at their pace. And for themselves, they now have the opportunity to actually become a performant teams. This is our current status to wrap things up. We have ramped up our approach to around 15 teams. We have built 40 microservices, which then make up 9 of those self-contained systems. We have 200 repositories and about 25 Lambda functions. And that slide is already 2 months old, so the numbers might have increased by that. We now can, in a half a day, bootstrap a new service from our service template, bring it into production, have monitoring and logging in place, and have an hello world out there so that the team after half a day can actually start working on the front end and back end and bring a new service in production. So one of the examples a month ago were actually bootstrap a new capability then, as you can see, in 7 days, which was quite astonishing for us. And another metric that's interesting is still our continuous delivery pipeline has a cycle time of about 20 minutes, which is good. But when you get used to it, you want to have a faster cycle time, for which we might move to containers. So this was my part of the story. I hand over to Konstantin.
Thank you, Christian. Thank you very much. So as you go back to your companies and think about how you can change your culture to become a much more flexible and innovative company, please think about the innovation cycle. Every innovation cycle starts with an idea, something you want to do, and then you build a product out of that idea, and out of the product you measure data, which is the feedback that your users give you about the product in near real time. And out of that data, you learn something new that you can use to create new ideas, and this is how the whole cycle works. And your goal is to accelerate that cycle, to make it as fast as possible. And as we have seen, all of these technical tools, cloud, microservices, CI/CD, big data, IoT, mobile, machine learning, BI analytics, these are great tools to accelerate the cycle. But it only works if you get the culture right. So as you go back and employ the things that you learned at reInvent in your companies, please think about the cultural aspects. Try to build small teams that are autonomous, that have the ownership of what you're building, where business, developers, and ops people work together. Read about lean business methods that can help you go through that cycle faster from a business perspective, and combine them with agile methods in the development layer of your teams, and then bring that on the street as quickly as possible and let it run through DevOps methods, which work nicely together with agile and lean together. Only if you combine all of these 3 layers into those teams and you make those teams truly autonomous, you will be able to accelerate the whole cycle quickly, also from an organizational perspective. With that, thank you very much for attending this talk. And I think we have some time for questions. If you have questions, please walk up to the microphone and state your question. Thank you.
Thank you.